Sure, let's go through the combinatorics of the birthday problem. Here's a birthday problem. Suppose there are n people in a room. What's the probability that two people share a birthday? Now, to solve the problem, I'm going to assume that the birthdays are uniformly distributed throughout the year, which is not true. For example, in the Northern Hemisphere, the months of August and September have more birthdays than other months. But let's forget that and suppose uniformity. What's this probability? To compute a probability, we compute the ratio of favorable cases divided by the total number of cases. The total number of cases in this scenario is easy to count because there are n people in the room, and if we forget about February 29, there are 365 choices per person, so the product of 365 n times is the total number of cases of the possibilities of birthdays in the room. So that's 365 to the nth power. Now, the number of favorable cases is actually very complicated to count. So, because out of all those cases, I have to try to count in how many cases there is a match, in how many cases maybe there might be two matches, maybe there is a triple match. So there's many scenarios to consider that makes this count very difficult. So we're going to do something else. Instead of directly counting the number of favorable cases divided by the total, we actually compute the opposite probability first and then compute that one. So what we actually want, the probability we want, will be 1 minus the not favorable cases divided by the total. Now, what are the not favorable cases? The not favorable cases are easy to count because are those cases where there is no match at all. So for no match, there's going to be 365 choices for the first birthday. Now, for the second one, we don't want to match that one, so we just have to avoid one. So it's 364 choices. For the third person, we have to avoid two birthdays. So there's 363 cases, and so on, up to the nth person, where there are 365 minus n plus 1 possibilities, so that there is no match at all among all those people. So what we get is the probability will be 1 minus the product of favorable cases divided by the total number of cases, or equivalent 1 minus 365 divided by 365, 64 divided by 65, and 365 minus n plus 1 divided by 365. So this is a formula for the probability of the event that there is at least one match. And then you can compute values. So if there is exactly two people, this is the probability of having one match, and that is 0.0027, which is 0.27%. So very unlikely with two people. If there are 5 people, this is the probability. So it's 2.7%. With 10 people, it goes to 11.7%. With 20 people, it's already 41%. With 23 people, is the first time that it goes above 50%. So it's already at 50.7%. With 30 people, it's already 70%. With 50 people, it's at 97%. So very likely.